going to look at how advanced AI is transforming operational efficiency, predictive maintenance, and energy optimization in large-scale facilities. So we have an excellent panel for you discussing industrial AI strategy. So I'm going to introduce, well, do you know what? Why don't you introduce yourselves? Because you know your names, your jobs, and what your companies do far better than I. Sumen, perhaps you can kick off.
Thank you. Thanks everybody joining this session with all of us today. I'm Sumin Chatterjee from HCL Technologies. I'm based out of London. I lead our data AI and industrial AI specifically for manufacturing, automobiles, and energy utility sectors for EMEA. And I'm in the industry for almost 30 years, specialization on data and AI and all other emerging technologies.
Thank you. Aurelien.
Hi everyone, and thank you for joining. My name is Aurelien De Croo. I work for Siemens Digital Industry Software as a solution architect principal. So Siemens is one of the global leaders in technology at the forefront of AI, industrial AI, and provide solutions from designing to operational efficiencies.
Thank you. And Paul?
Thank you. Thank you everyone for coming. I'm Paul Serin. I'm a Chief Technology Officer of Nyxium, which is a decision infrastructure platforms that will help data centers and energy developers deploy at the speed, scale, and safety that the world now requires. Before that, I was actually a nuclear engineer for the past 9 to 10 years. So I was on the power supply side of the data center stack. That's what got me into data centers, is how can we use nuclear to help data center deployment. And now at Nyxium, we see that all of this needs to be solved all together. So can we use AI to help data center nuclear, and can we use nuclear to help data centers? So thank you.
Okay, gentlemen, thank you very much. It's disorientating for us all wearing these headphones and hearing the extraneous noise bleeding through, but I know our audience can hear you perfectly well. So let's crack on. Aurelien, we're moving from data storage data centers to intelligent AI factories. And what does that mean about the design for that specific purpose?
Yeah, so I think what we call AI factories are designed to, design for the growing need for LLM consumption. So, and they are designed basically to convert energy into AI token. So they are more complex and more larger facilities. So that comes with a lot of challenges in terms of optimization, energy optimization, connecting to the grid. And I think, industrial AI is all about making smarter data center that are optimized for reducing energy, for cooling, for instance, predictive maintenance, and continuous monitoring. And I think digital twins are becoming essential to manage this complexity. So from a designing perspective down to continuous operation and monitoring. So it starts with designing. So it's running multi-physics simulation when you're designing your hardware, and from the chips down to the data center and the facilities. And it goes also to, so it's physical simulation, like thermal simulation, to optimize cooling and heat management. It's physical simulation. It's also designing these very complex chips that are now trillions of transistors. And it's taking these very heavy simulation models that takes a lot of time to run. We are producing what we call rapid order models. So they are lighter version of this simulation based on neural network. And they run faster, and you can run more simulation, so you reduce your time to design your facility and adapt. And they can be run onto real-time data, so really digital twins. They are combining this digital world and this real-time data, so they're coming from the sensor, your IoT, your BMS, and you're sending them through message buses. So you're able to really apply physics AI to to your operations. So managing, reducing downtime, for instance. Um, but yeah, so I think industrial AI, definitely we see more complexity and change in the design of these new AI factories from data center. And I think digital twins and AI, industrial AI, is helping to cope with this complexity faster and better.
Any thoughts, panel, on the complexities and challenges which we have now and will face that we haven't had before?
Yeah, I think there are quite a few challenges, right, in order to cope with the AI workload. I think key thing is the workload. Previously, if you see the traditional data center, the workload was different than now. Like in order to, for example, if you wanted to do any digital twins or anything, the enormous amount of data, trillions of messages or data you need to communicate between your instruments or products, or if you wanted to build your, say, car or any product factory data, right? So that means you have to build your nervous system and your I would say the spinal cord of the system, right? I think they have to be completely redesigned, and I think that is quite challenging. And then I think that's where you need to build your data center ground up and either follow some of the I would say the blueprint what Siemens and others are doing with NVIDIA, for example. So how they are building your specifically so far data centers was like a room-centric, right? Now you have to focus more on the rack, how you condense your like a new cheap technologies within the rack, and that means that you have to change your floor. You have to accommodate that enormous amount, or I would say the weight it can carry on the floor. It's not like a lightweight technology. So, for example, one block could be like a 3,000 kilos of these things. So there are loads of things you need to consider, and more on that network side, how they communicate, like hundreds of thousands GPU will communicate. So your infrastructure and communications will be different. So think about those things, and lot of this design, I think you have to think through to become more AI native, not like fitting an existing data center like a for working for AI. So it has to be new way of thinking for the new type of workload.
And maybe to extend on that a little bit, so that was about the nervous system of AI, so the building and the rack. But another problem that is a reality today and not for the future is how do you actually even get to the point where you're allowed to build and operate your data center? And that's a big bottleneck that the industry is facing today. So there is, this promise of exponential demand of AI driven by, AI applications, cloud services, and so forth. But the physical infrastructure, the place where you can actually build your plants, that cannot scale exponentially. And so a lot of people today are, stuck because, well, you can acquire a cheap land, and in the past it was what was happening, and connect to the grid. But right now it's just not possible. The interconnection give you 5 to 10 years in the US, more in the UK sometimes. Or even if you get an interconnection, will you get this will-serve underwriting of power? Will you get this will-serve underwriting of water, for that matter? And even if you get that, well, maybe there's a community around it, around the place you want to build, that will say, well, we don't want this project to get built. And I think in the world there is almost $100 billion of projects that were stalled or rejected last year for data centers because of community rejection exclusively. And in 2025, the trend is just accelerating. Actually, I think it's from January, there is as many that were rejected this year compared with last year. And that's, again, one part of the picture. And now you bring back, permitting that change that are also influenced by community behavior. Typically you see in the US in many places that zoning related to water withdrawal change. And then AWS, Google, they have to pledge, well, let's use wastewater treatment because that's how you get your social license to operate or keep operating. And if you can't operate, then you'll lose a lot of money. And so that's a problem that is now, which is in the back end of what we were just discussing before. So, and that's a reality, I think, that needs to be addressed as well.
So let me put it in simplistic terms. We all know about the reluctance of communities to allow a dirty great data center on their doorstep. From the design up, you are designing your own microgrids. You are designing better cooling systems. You're designing much better community benefit. Is it simply then a matter of dumb engagement by us? Because you are designing these things from the get-go. Paul?
So yeah, I think it's both a design and a good narrative as well. I think a lot of the thing, and the topic is, of this talk is using AI to optimize the infrastructure that will enable the development of AI, which is the data centers. And the narrative also has to come to the public. There is some irreducible thing that AI cannot do, which is local engagement. And so we can do a lot of things as an industry, like optimizing the water cooling of your data centers, or using wastewater treatment, or there was waste heat as well, etc. But I think we need good PR to go to the community and say, well, we do that. First of all, we invest, and on top of that, there is a lot of benefit for the community, which is a lot of indirect jobs. We power your phone and so forth. So I think it's a combination of doing it, optimizing the design, going to places where it's not underwater stressed or where there are a lot of vulnerable populations, and also engaging with the community.
So on this subject, industrial AI data centers are so hugely energy hungry. How do you plan the energy needs right from the beginning? Paul, can you touch on that? From the very planning stage, how do you build a credible energy strategy right at the beginning that is focused on an industrial AI center?
I think I can start and then you can add.
Sure.
I think there are, I think Paul was mentioning, right? He comes from nuclear, he had the nuclear energy background, right? I think if you see these days, I think the huge demand from Google, Amazon, and all the top hyperscalers, right? They are the way the new data center you are building, like it's the one of the basic principle is the bring your own power with you, right? So that means either you bring the nuclear power energy with you, or some different kind of power you create, or sometimes there are new UPS technologies which are very much aware of network and speed and lot of the intelligence built in there. So I think that way that is very much evolving. But I think nuclear is the key power for most of them now. I think at this moment, all the organizations, hyperscalers, are considering nuclear power, and I think that's one of the key source of energy to support this kind of a huge amount of energy needed. You can add on top of that.
No, thanks for the answer. I would say nuclear is great. You can get PPAs to make sure that you're going to get the power, whether it's virtual or physical PPAs. But there is also, or bring your own power, build data centers on site, maybe bring a gas power plant because it's going to be online much quicker. So you look at the timeline as well here. So nuclear is going to take a little bit of time. So there's a lot of companies in the US, and I think there is two projects in the UK where it's bridge gas to nuclear. So we're going to bring some natural gas because you can maybe power within 12 to 18 months. Compare with the 5 to 10 years on interconnection is better, and then slowly bring other clean energy like nuclear or renewable. But that's one option. It's maybe not the most economical. And so what you need, again, I think, is to look at the big picture. I mean, I don't think if there was a good strategy to power, I think, everyone will be successful. So I think it's a difficult question to answer, but you can look also at policies. We talk about, a big picture with all of these signals all together. Policies can be one, if there is incentives to build in a certain, growth corridor, these companies, they have to, look for that. or if there is an incentive for data centers to provide non-firm connections and actively participate to the electricity market with ancillary services, etc., that could help accelerate also the deployment of data centers. So I think it's looking at all of these signals.
It'll take you 100 years to get planning, certainly in this country, for any form of nuclear generation that's not already provided by our main plants. I mean, there's no community in this country will accept that.
I think a lot of the cases, this planning also designed by AI. So we are taking help of AI to
That's the problem.
design some of this planning, and even, for example, we are building new materials for battery, for example,
Yeah.
right? How they are built. I think that way. So we are taking help of AI itself to build some of the design, and other thing is like a little bit of, if you take a step back, so a lot of the cases, these power hungry things happens in the when you actually send your signals to the chip and those kind of design, right? So in the architecture level, when you are using more AI or AML type of technologies, you can design your architecture so efficiently so that you do most of the processing in one layer and then send those to the consolidated way to the next layer. So that way you can save trillions of, I would say, signals, and you can save a lot of energy. So I think you can build your architecture the way so that it is more energy efficient. It doesn't create extra workload for your data center. So there are a lot of different layer design needed, and you can do also in the architecture level to solve that particular issues.
Yeah, and to add to that, I think predicting the demand. So the difficulty is also how to plan for future unknown demand. What time of the day you're gonna have this peak of need of powers, and this is where you're gonna source your energy from as well. Where do you have the cleanest and the safest and the cheapest energy? So it comes with this predictive. AI can be also an answer in terms of predictive, but it's also coming to having the data to train this industrial AI as well.
How close are we to a situation where an industrial AI data center is self-healing? It's managing its own power swings. It's managing its own cooling failures, and it doesn't require a human to intervene. How autonomous and self-healing are we? And what steps do we need to take to get there fully?
Yeah, I think we see industrial AI, a lot of good use cases like predictive maintenance to reduce downtime. But AI is also coming with a risk. You have operational risk, finance risk, intellectual property. So I think it's important to make the distinction between consumer AI and industrial AI. So industrial AI has to be reliable, secured, explainable. So it's not necessarily the most complex, LLM models, and also it's a question of how you train this model and who is developing this intelligence. So do you have the right people that are knowledgeable, data center operation people developing these models, and it's a question around also governance of industrial AI. And yeah, because if the AI is making a mistake, that can have huge financial or operational risk. So I think it's fine to have models, machine learning models that are 95% accurate for a marketing prediction, but when you have human and financial impact, so you need models that are also aware of the context and the consequences. So I think we see that we still see some human in the loop as well. So you'll have an interaction between AI and the people at the beginning. And I think to address the failure of AI is also what is required. So AI can fail if you haven't trained the AI on the right data, or you don't have the data ready to train a model, or you're overfit. We also have a lot of data from data center, right? We can train the models, this AI on. You have data coming from your IoT, your systems. But what's missing is, relation between all these data that's in silos. So I think we need also to build the connection, the semantics around this data for AI to be able to reason across data. And if you look at more advanced type of AI like LLM, I mean, they're very powerful, but they are very generic as well. They haven't been trained on non-contextual data, so which is good for consumer AI. But again, you need to bring some context to train this new form of intelligence.
No, and to piggyback on that and tie it to another topic that we discussed previously is the, before we go to self-healing, I think another questions we need to solve is, well, if we use, all of these technologies for, operating autonomously data centers, for instance, the impact of these operations are enormous in terms of capitals and for the communities as well. And so if we don't put some guardrails with human in the loop, as Aurelian mentioned, we're going to add another, layers of mistrust maybe from society, which is already pretty high, the rejection. So I would say the self-healing will also come with technology, but, supported by a lot of human in the loop, I guess, as Aurelian mentioned already.
I think one other aspect I would say, so self-healing these days, there are a lot, I think a lot of organizations are already in that path to embed AI ops and others to do the self-healing and observability layer and monitoring. But I think if you consider that this is not just isolated self-healing is a one property of this whole equations, right? I think you need to make sure that fully in a fully autonomous system, like where you are building the autonomy, the way it, for example, a lot of the car manufacturing organizations these days, right, in the factory, the way the production happens, everything starting from the design, your validations, everything is autonomous and in an autonomy way it's doing. So that includes the self-healing, that includes the validation of the like kind of a quality inspections without a human intervention. So I think there are a lot involved and self-healing is that's why so important that in every single steps has to be so automated so that you starting from the design and productions of your car and coming out of that factory in a proper quality inspected way. I think that's where the market also, if you see that actual consumer part of the AI, right? I think not in, it helps you to take this infrastructure and AI so that you can reduce your production life cycle of the products, right? And that's where I think every single steps of your factory and especially AI factories these days are so important. And I think healing is one integral part of that.
Can we move on to the big question of redundancy? I mean, AI data centers are harder to build. They're much more involved. They're costlier. They require more energy and the community controversy that surrounds them. So they can potentially be slower to build. How do you either avoid building in redundancy from the moment you start laying the first brick or pipe in the ground, particularly with chip technology? Who can pick up?
So from the redundancy point of view, I think these days, I think one of the key aspects you need to consider, obviously redundancy is one side, but it is more of a, if you see the way the modern data centers are and the racks are created, like it should accommodate the future hardware there, okay? So that means like, for example, it's not like your traditional data center bring some GPUs and put it there in yourself. You have to build it such a way so that it can communicate between hundreds of thousands of GPUs or TPUs to that way, right? So redundant, the failure of that infrastructure, I think a lot of the cases you cannot even afford that failing hundred thousands of GPU communicating between them. So that means you have to consider a new way of building your data center. So traditional data centers are what we call the north-south type of design. But this design for AI native or purpose-built AI, you have to build it east and west. That means so they can communicate in the network layer such a way. So redundancy, a lot of the cases like the space problem or cooling and all other things, right? It's not like you will have three different center, or if you fail in one places and you can go to others, because these data centers are, if you see that very few data centers in across the planet like that, right? So you have to manage more fault tolerant, I would say, rather than redundancy. It's a more fault tolerant architecture way of building this kind of infrastructure. I think that is quite key.
Yeah, and with you know, changing hardware, constantly evolving, I think,
Yeah.
and managing this fast need of commissioning is critical. It's integrating, hardware with software between your IT and your OT, and so we think things helping like virtual commissioning as well, which again is using this industrial AI to do a lot of testing to make sure we have systems that are resilient and ensuring redundancy.
At what stage does that sort of deployment risk prevent projects from proceeding, or is it better perhaps just to make that start and not go for perfection? I mean,
I think perfections is needed to some extent, because obviously this design has to be so such a way so that all the communications between different components are absolutely in a, I would say, in a state so that it can maintain the latency, it can maintain that trillions of signals between them in a micro milliseconds way, right? So I think perfection is needed, and one other thing you need to remember, for normal enterprise or consumers of these technologies, I think a lot of these problems are solved by AI companies, right? For example, hyperscaler, and they're spending hundreds of billions on that, right? So I think you can be a consumer of those technologies. So for example, Aurelian mentioned a lot of LLMs and others. So the way you do that, you use those LLM providers, they are building those infrastructure, they are doing the perfections in terms of the design, and you are using the API and other technologies to leverage their models, right? So the way this consumer and producer is changing now, and so I think how you consume these AI technologies, I think instead of being a perfections in your data center design, you can possibly consume a lot of these AI technologies from the producer of the AI. So I think the equations is changing now. So your relationship with the AI companies are changing. A lot of the cases, AI companies like Anthropic and others, you see that they are also giving you the service. They are building that. They are designing that because they are close to those technologies. Yeah. So I think there are massive disruptions in this area. Perfections is one side, but I think more of a, I would say, the collaborations between them and how you are collaborating or orchestrating that is another key factor.
Does the risk lie with getting the buildings, the infrastructure right in the first place, and how can you be sure that you have that optimized and you can predict for the next 10 or 15 years that physical infrastructure will be appropriate to any retrofitting you subsequently need?
Yes, I think that's why the AI factory coming in the picture. If you see that these days, NVIDIA and others, I think they are building, my own organization also build AI factories, for example. So we call the cognitive infrastructure, so that infrastructure embedded with the intelligence, right? So that is preparing you for your future with the for your physical AI, or we call the kinetic AI as well, so that it has got a lot of different aspects. And when you build the physical, I would say that AI factories. So those factories are basically like a smaller scale of those big, large what AI companies are doing for your own running. So I think that's kind of a new way of accommodating this the future needs, so that you can accommodate future chips there, future hardware there. You are prepared with the self-healing and others, and how you communicate between chips. And lot of the cases, another problem these days, I would say problem, or it's one other requirement, is the sovereignty, right? So a lot of the cases is not so easy to switch from one locations to another locations because of the lot of different sovereign requirements, right? So that part also need to consider.
Which is a subject we're going to get to on this stage later on. It's just occurred to me that with 14 minutes to go, I really ought to ask whether you in the audience have got any questions that you would like to raise. Any hands fly up and we can get a microphone to you? No? Fantastic. Well, I'll carry on with my own sweet agenda then. How we talked about self-healing data centers, and perhaps allied to that is the use of the arrival of physical AI, robots within the data center. Will your industrial AI stack be managed by robots inside? To what extent can we knock the human out and really fully automate? Aurelian, any thoughts?
Yeah, just to add on what I was saying earlier. So I think you might still have a human in the loop. Industrial AI has to be safe, secure, interpretable as well. So I think it's all about first having the right data. It's about also the context. So this AI I think is helping, but you need to they need to understand the consequences. You don't want an AI to wipe out a full database or do some operation that's gonna break your operation completely. Yeah. So how do I make sure my robot is aware that he's doing a maintenance on this rack that's going to impact maybe a banking SLA tier 1 application? That's all about not only having data but having the context around the data. So providing this context and build this intelligence with contextual data, and also the execution. So where is it faster to deploy this machine learning model and this intelligence and these robots? Is it on the cloud? Is it on the edge as well? And who is managing and monitoring the accuracy of these robots? There's a lot of orchestration and governance. So there's one solution I'm looking at more specifically to build this kind of contextual and semantics is a different way of modeling the data. So you have something like knowledge graph. They enable you to build this context. So basically bringing relationship to the data that is still siloed. So between the data you have from your simulation, your data center, you want to understand the impact with your contract and your end application, for instance. So they're kind of describing the data in a kind of a web semantics way that is going to enable to bring more governance around robotics and industrial AI.
How safe is the scenario of having robotic workforce in there, and so, where does the human in the loop stand, and how does that actually work?
Yeah, so I think it's a kind of a hybrid workforce in a way between this AI and the people. So you maybe augment some of the decisions, but yeah, if maybe sensitive use cases or decision, I think you still need to have the human that has this real-time information to him. I think digital twins and more immersive as well. So we're trying to bring the metaverse. That's something we're working at Siemens, brings this metaverse solution of 3D representation of your data center, so they are in control of the operation of your data center.
I think I love this question. Basically, this is so fantastic, right? What I called, I think this is one topic. Like I'm writing a book called Co-Evaluation. I think towards the end of the year, you will see that like how we are co-evaluating, right? Evolving us in terms of with the human autonomy situations, right? If you see that today's lot of the factory, I think especially car manufacturers and others, right? I think they are so much, I think, autonomous infrastructure, and all the robots are there. So basically everything is managing by robots, right? So the question obviously coming then, what is our job there? Like how you handle the exceptions in the robot, right? Their decision making, and putting them in terms of the right set of context, and contextual informations. I think those are the area like it's like as Aurelian was saying, right? I think that's where a lot of human input coming into the picture. So even though a lot of the decisions and everything in the factory, warehouse, even Amazon is doing, for example, or if you see that BMW or Mercedes and every car companies, I think they are using the autonomous robots. But in terms of some of the company like Chinese companies like BYD and others, they were using robots in such a fantastic way. So they have reduced the production life cycle even so fast, so they can release, I think, new car, a new model in exceptional less time. So I think that's where I think human and the robots are coming together in a, I would say, the augmented intelligence way. And I think that's the way to future, and I think that's the way we are evolving ourselves in the market.
No, well, on our side, we see maybe the use of robots, not from the operational perspective, but the construction perspective. So, all of these big projects, they are, they say they all suffer from cost overruns and go over time, and over budget. And if you can, bring more robotics automations in the constructions, maybe you can mitigate that a lot. And we see that in the nuclear industry coming more and more actually at the construction phase, which is, less how do you say, safety grades than at the operation side. But I think even before when you build, um, I think there is also a useful case for it. Building cars, well, build data centers with automation and robots. So would be
Sure,
useful.
sure. Okay, so to wrap up, can I ask each of you, what are the challenges, what are the things that you can't solve at the moment that we need as an industry going forward? What are the things that keep you awake at night because we're not there yet? What are those big challenges? And what solutions? How are those solutions being tackled? Maybe you're part of that solution. What are the blocks for you at the moment?
I think there are from any AI technologies, right? I think industry is expecting both top line and bottom line things, right? It's not like some magic things you put on your desk and it will do some magic things, right? For your industry. So every single dollar you invest from any enterprise, whether you are in a consumer of the technology or producer of the technology or user of the technology, how you are getting return or multiplying that is the important thing, right? So in terms of that means in your enterprise chain, right? If you consider your enterprise or your organizations has a different block of business functions, right? How you embed that technology within those business functions so that can help you to generate more revenue side or create a new revenue or kind of a optimize your operational efficiency or those kind of things, right? So that is the key, and that could be coming from your data center, the way you design, or that could be the way you are building technologies on top of that. So I think that is one of the key challenges, I would say, that how you use the AI in an efficient way for your own organizations. It's not like Tom is using in this way, then that will work for me, and it will work for somebody else, right? You have to think like it's a technology, it's a fluidity with a fluidity. So it has to be kind of a, I would say, tailored for your own organization's own business model.
Okay. Aurelian, what's the next big leap for you?
So also coming from an AI perspective, industrial AI, I think the main challenge we see is to deploy this AI at scale. We need a lot of work still around data management, and building like the data fabric foundation to get the return on investment from deploying more safer and trusted and governed AI. So it goes with still a lot of data engineering, with data being very siloed, all the data you can get from these facilities. But I think it's key, yes, to build this context around data as the foundation from AI reasoning across all the data and coming, from designing all the full life cycle of these facilities and operation.
And Paul.
Well, from the aspect of deployment of these AI factories, AI infrastructure, as I mentioned earlier, I think there is a lot of data as well for us, fragmented that don't really talk to each other, whether it's policy, permittings, community, sustainability, etc. And I think in the future they need to talk to each other. And I think that's what we do at Nyxium, is to be the cement for all of these data that we incorporate in our decision engine and turn that into decision-grade insight. They have to talk to each other. For the UK, data centers is now a matter of national interest. So policymakers need to talk to data centers, developers, etc., and build the right policies for enable that deployment. And so, yeah, putting all of these together, I think that's the big challenge for us. And that's what we intend to solve.
Thank you. I've never had a conversation that involves AI where it hasn't boiled down to getting the data sorted, and I've never had a conversation about data centers when it hasn't also always fallen down to proper engagement, either with the community or with the regulators and the government, to ensure that we have either planning or the right infrastructure in place. Panel, thank you very much indeed. It's been quite a lot of fun.